Alrighty, welcome back, boys and girls. It's your man, Math Man Mitch Shane, coming to you live from Summon Academy. In this video, still working on unit number 5, lesson 15. We're going to be talking about some cones today, and so we're going to be comparing some cones and cylinders. So our lesson objective is we will be able to calculate the volume of a cone and cylinder given the height and radius, and then also explain how we got that solution method. So for the first part, it says the cone and cylinder have the same height and the radii of their bases are equal. So then it says which figure has a larger volume. So notice how it gives it the area of the base is still the same and the height are also 8. And so it says which do you think is larger? Well, we can say that the cylinder has a larger volume because if we filled in that top part on the cone, it would then make up the cylinder. So the cylinder is going to have a larger volume. And number 2, it says, do you think the volume of the smaller one is more or less than half the volume of the larger one? And explain your reasoning. So what we're going to do is say this. We're going to say, I believe, or I think that the volume of the smaller one is less than half of the volume of the larger one. So, and we'll talk about that here shortly, like how much smaller is this cone compared to the cylinder. And then it says for the part 3, here is a method for quickly sketching a cone. So it says to first draw an oval, and then it says draw a point centered above the oval. Notice how it's up here, and then connect the edges of the oval to the point. And it says which parts of the drawing would be hidden behind the object, and we would say we would make those the dashed lines. And so what we're going to do is we're going to practice being able to draw these out. So I'm going to draw some of these cones. I'm going to draw them of 2 different sizes, and we're going to label them that it's going to be a radius r and the height h. And so what we can do is I'm going to actually flip it around. I'm going to do it like this. I'm going to draw one of them like this, draw the oval, draw the point centered beneath it, and then draw the connected parts, or the 2 sides. Let's do it like this. Something like that. Again, it's not going to be perfect, like I said before, but we want to make sure that we can label and we can say, okay, that center point in the base is going to be to the edge, and so we're going to say that's r, and then the height, meaning from the top to bottom, is going to be h. So you can just label that as h. And then I can draw a different sized one when I actually do it on its side, so that way it's a little bit larger. So I draw the oval, draw the point, and I draw the lines connecting the side to the open end. Again, from the center to the edge is the radius, and the height is going to be on the side. So even though it's shaped in different ways, we still label those parts the correct ways. Alright, and before we move to the next part, I'm going to actually show you this volume video first. So let me get rid of that, and let me switch over. So usually I like to do this with you guys, but unfortunately the solids that I have don't work out properly. But what it does have is if you have a volume with the same height, or sorry, a cone with the same height and the same base as a cylinder, what's going to happen with the volume. So let's watch it here. And this is also on the, notice how it fits inside of it. This is also on the OpenUp website as well. So notice how it's the same height, it's the same base because they fit inside one another like that. And so what they're going to do is going to fill up the cone, and we're going to see how many times they fill up the cone and pour it into the cylinder. So they fill it up to the very brink, pour it in once into the cylinder. Then they're going to fill it up the entire volume of the cone into the cylinder again. So that's a second time. And a third time, actually, they're going to be able to fit it in to the absolute brink, or to the absolute edge. Notice how it's almost overflown, but it's not quite. Is it going to overflow? No, it goes perfectly in exactly 3 times. And so what does that mean for our volume? Give me 1 second here. All right, so what does that mean for our volume? So we're going to say that if a cone and a cylinder have the same height and their bases are congruent circles. So that means that they have the same height and the same base. Well, for that first part, it says, and remind yourselves again, what does it mean for congruent? Well, we can say that congruent just means the same. So it says if the volume of the cylinder is 90 centimeters cubed, because we're talking about volume, what is the volume of the cone? Well, we're going to say since the volume of the cone is a third of the volume of the cylinder, what we can do is we can multiply it by 1/3. So we're going to take 1/3 times 90, or we can do 90 divided by 3, and we're going to say that's going to be 30 centimeters cubed. So our volume of our cone is going to be 1/3 the volume of the cylinder. Then it says if the volume of cone is 120 centimeters cubed, what is the volume of the cylinder? So now we're going to say it's a little bit similar. We're going to say since the volume of the cylinder is 3 times the volume of a cone, we have this. So we're going to actually have 3 times 120. And so we're going to say this is going to be equal to 360 centimeters cubed. And for number 3, it says if the volume of the cylinder is given by the formula V equals pi times radius squared times h, what is the volume of the cone? So we can either write it as an expression of the cone or explain how that works. So what we can do is we can do it like this. We can say we can take the volume or the formula of the volume of the cylinder and divide it by 3. So that means this. We're going to write it like this. We're going to say the volume of the cone. The volume of cone is going to be equal to, well, that's just going to be pi times the radius squared. That's our big B, our area of base, times h. But we now have to just say it's divided by 3. So either way, it still works. So notice the relationship. The cone volume is 1/3 of the volume of the cylinder. All right, moving towards the bottom now, it says calculate that cone. So it says here is a cylinder and a cone that have the same height and the same base area. So it says what is the volume of each figure and express your answer in terms of pi. So that just means we don't have to change it to 3.14. So make sure some stuff that we do know that if the diameter is equal to 10, that means the radius is going to be half of that. So we're going to say the radius is going to be 5. And also too, that means that these two bases are going to be the same. So once we find the base of one, it will be the same as the other. So we're going to say, all right, first off, find the area of the base. Our big B is going to be equal to pi times the radius squared, which we said is going to be pi times 5 squared, because that's our radius. So that means our area of each of these bases is going to be 25 pi. Then we could say for the volume of this cylinder, we can say the volume of the cylinder, so let me write cylinder, is going to be equal to big B times h, which is the same as saying we have 25 pi times our height, which is 4. So the volume of the cylinder is going to be equal to 100 pi. We'll say units to the 3rd power. So that's going to be the volume of that cylinder. However, now we have to find the volume of the cone. So I'm going to say, again, volume of that cone is going to be similar setup. It's going to be B times h, our big B times h, our area of base times our height, divided by 3 now. So we're going to say, again, still B is going to be the same. So we're going to say this is equal to 25 pi times 4, or you could say, actually let's do it like this, we can say it's going to be the same. We're going to say it's actually 100 pi divided by 3. We're going to say that's going to be units to the third power. Because we don't have to do any calculations, because we know the height and radius is the same for both the cylinder and the cone, and so all we have to do is take that volume divided by 3. Again, leave your answer in terms of pi because we have to say that it's going to be 100 times pi divided by 3. All right, and at the very bottom it says here's cone. It says what is the area of the base? Express your answer in terms of pi, and then what's the volume of this cone? And leave your answer as pi as well. So we're going to say, all right, find the area of this base. So let's do that. So I'm talking about, all right, big B is equal to pi times the radius squared. So we're going to say big B is equal to pi times 6 squared, which is the same as 36 pi. And we're going to say units squared since we're talking about area. So that's going to be the area of that base. And so now if we talk about the volume of that cone, so we're going to say volume of the cone is going to be equal to big B times h over 3. So we're going to say volume equals, we're going to say 36 pi times h, which is 8, divided by 3. And what we can actually do is we can simplify. I know that 36 is divisible by 3, and so this is going to be the same as 12 pi times 8, which is the same as 96 pi. And we're going to say units to the third power because we're talking about volume. So make sure you can leave your answer in terms of pi. All right, moving to the back now, it says a cone-shaped popcorn cup has a radius of 5 centimeters and a height of 9 centimeters. How many cubic centimeters of popcorn can the cup hold? Again, notice it's saying cubic centimeters, so we know this is going to be volume. So we're looking for volume. And it says use 3.14 as an approximation of pi, so that way we will get a numerical answer without pi. So what we can do is first I'm going to draw that little popcorn cup like this. I'm going to draw that point at the end, connect those sides like so, be able to label the radius and so we're going to say r equals 5, and the height of this, we're going to say h equals 9. So now that we have our labels, we can find the area of our base. So we're going to say big B equals pi times the radius squared. We're going to say big B equals pi. We're going to say, actually, instead of pi, we're going to actually use 3.14. Got to be careful there. 3.14 times 5 squared. And so that is going to be equal to 25 times 3.14, which is going to be 78.5 centimeters squared. So that's going to be the area of the base, but we're looking for the volume of this cone. So let's find the volume. So we're going to say, change the color here, let's say volume cone to be equal to big B times h over 3. So we're going to say the volume is equal to, we're going to say 78.5 times 9 divided by 3. Again, you can type this entire thing into Desmos, that way you get an answer, but we're going to say our volume is going to be equal to 235.5 centimeters cubed because we're looking at volume. All right, moving on to those practice problems. On the back, for that first one, we have a cylinder and a cone that have the same height and radius. The height of each is 5 centimeters and the radius is 2 centimeters. Let's calculate the volume of each of those. And so let's say, all right, let's say, all right, we have big B. It's going to be the area of the base for both of those because it has the same height and radius. So we're going to say radius squared times pi is going to be our area of the base. So we're going to say this is going to be pi times, let's say the radius is 2, so we're going to say 2 squared, which the area of each of those bases is going to be 4 pi. So now let's find, we have the area of the cone, or sorry, let's do the cylinder first. Let's say volume of the cylinder is going to be just B times H. And so we can say the volume of the cylinder is going to be equal to, we have 4 pi times its height, which is 5. And so the volume of the cylinder is going to be equal to 20 pi centimeters cubed. So that's going to be the volume of the cylinder. So now let's take and find that volume of the cone, which is going to be real easy because the volume of the cone, try to draw that V a little bit better, there we go. So the volume of the cone is just going to be the area of the base times the height divided by 3. So if we want to, we can take this value that we have and use it here. So we're going to say volume of the cone to be equal to 20 pi over 3, and we're going to say centimeters cubed. So make sure you can see how those work. For number 2, it says the volume of this cone is 36 pi cubic units. What is the volume of a cylinder that has the same base and area, same base area and the same height? So we actually have to find, this is similar to the previous video that we had, but what we can do is we can say, remember, the volume of the cylinder is 3 times the volume of the cone. So all we have to do is say this. We can say, all right, well, we can take the volume that it gives us, so we're going to say 36 pi, and we can just multiply it by 3 because we're not going to get the cylinder this time. So we're going to say the volume of the cylinder is 108 pi cubic units. So that's going to be the volume of the cylinder. So very little calculation, but we can actually find what it gives us. For number 3, it says a cylinder has a diameter of 6 centimeters and a volume of 36 pi centimeters cubed. Let's sketch the cylinder, find its height and radius in centimeters, and then be sure to label your sketch with the cylinder's height and radius. So this is what I was kind of talking about. I thought this was the 36 pi that they're talking about, but this is similar to the previous video where we have to solve for those dimensions. So let's kind of sketch our picture here, and I'm going to actually do it on sides, that way it's a little bit easier to see. So I'm going to have, all right, here's the radius, which if the diameter is 6, half of 6 is going to be 3. So the radius for this one is going to be 3. And we're going to say, okay, here, draw our cylinder, and something like this, have that dash line, oval on the other side, and our height is going to be equal to, we don't know yet. So we're looking for height. However, we do know that the volume is going to be 36 pi. So let's remind ourselves, we're going to say, all right, volume of the cylinder is going to be the area of the base times the height. What we have and what we can find is we can actually find that area of the base. We can say big B is going to be equal to pi times the radius squared. So we're going to say, all right, we have big B equals pi times 3 squared, which is the same as 9 pi. And so what we can do is we can plug in some of these values. So I'm going to say this is going to be 36 pi. And on the right side, we have this big B, the area of base, we have that as 9 pi. And we don't know what h is, so we're just going to leave it as h. And so what we do is that one-step equation, divide both sides by 9 pi. And so if we divide both sides by 9 pi, we're going to say that h is going to be equal to 4. So we're going to say it's going to be 4 centimeters. So our height is equal to 4. And for the last one on this page, at the very bottom, it says Lynn wants to get some custom t-shirts printed for her basketball team. Shirts cost $10 each if you order 10 or fewer shirts, and $9 each if you order 11 or more shirts. So part A, I want you to just fill in that graph, sketch some points on here. So we're going to say, okay, if you buy 0 shirts, it's going to be $0. if you're going to buy one shirt. Again, we know that if it's 10, so let's actually start there. It's $10 each for 10 or fewer. So let's start there, and that actually is going to be the point 10, 100. And what we can do is we can make that pattern going down because each shirt costs $10 if we buy 10 or fewer. And then for the next part, it says $9 each if we order 11. So what does that mean? Well, we have to change it up a little bit. So if we order 11, each of those is going to be $9, so that we actually end up at 99. So we're going to start it right here, just below 100. Similar idea, we're going to be at 108. We're going to be at 117. We're going to be at 126, 135, and just below that is 144. So notice how it changes because those pricings are different. So we did part A. Again, graph out those points. Again, notice that change after 10. It says there are 10 people on the team. Do they save money if they buy an extra shirt? So let's find out. So what we can say is this. So I'm going to say part B, I'm going to say yes if if 11 shirts cost $99 and 10 shirts cost $100. Even if they split the cost of the extra shirt, they will still have that extra dollar. And in part C, it says what is the slope of the graph between 0 and 10, and what does that mean in our story? Well, that just means that in part C we can say it's $10 per shirt, meaning for every one step right we go up $10. And so that means the price of the shirt when you buy 10 shirts. And then for part D it says what is the slope of the line or the graph between 11 and 15. So it's talking about that purple line now. So what does that mean in our story? So we're going to actually talk about, and we're going to say that it means that it's $9 per shirt and the price per shirt when you buy 11 or more shirts. So make sure you can graph those out for yourself. And then lastly, but certainly not leastly, for our exit ticket, it says a cone with the same base but a height 3 times taller than the given cylinder exists. What is the volume of each figure? Express your answer in terms of pi. So what you have to do is you're going to say that this is going to be radius and this is going to be height. And what I can do is I can actually draw the cone. I'm going to say, okay, if this is our cone, something like this, not going to be perfect. Try that one a little bit. Oh man, I'm really struggling. There we go. Again, it's going to have the same radius, so our radius r is still going to be 3, but the height is going to be 3 times taller, so our height has to be 12 this time. So what I want you to do is find the volume of each figure and express your answers in terms of pi, so you can just leave it as pi. So be sure to ask questions, check with me as needed, and as always, super slam that subscribe button.